Welcome to Infini Models. I'm Jason, your host, and I do models and I guess electronics. We are working on our Switch. This is going to be the next part, and I think I may have discovered a flaw here. So let me give you a quick overview of where we're at here. So let's go to this camera, turn off the meter for a second. So this is the switchboard. So this BQ chip has been replaced. This the USB-C port has been replaced. This chip, this M92, is the charge control chip. I thought I was going to replace that because if let's do this. Let's check. Let's put the microscope in the top corner here, and let's look at the fuse here. Let's look at this fuse, and then in the main camera we'll take our handy dandy power meter here, and hopefully I can get this all in the shot. So I got my power meter plugged in, and let me plug it into the switch here. So that is, where's that fuse at? I just want to get the fuse in there. So there's the fuse. There's the fuse, and let me see if I can get the power meter there. So, oh, that was worse. So there is the power meter. Right there, it's saying 15 volts. Yeah, I know it's facing the wrong way. I'll fix that later. Let us get the meter back on, and let's go to volts DC. I have to change it on the voltage, DC voltage. So I have volts DC. I will. Oh, I just moved it. I have to change probes because I planned on showing you something else. So let's go to volts DC here, and let's check that fuse and see what voltage we have on that fuse here. If we look on the other side of that fuse, we have the 15 volts, what the meter is giving us. So that immediately made me think that this chip right here was the culprit. But there's no shorted capacitors or anything around that fuse. So let me just take this and move my DMM up higher. So I'm going to go to the big view of the microscope and get the other camera out of there. And I'm going to show you what I found here. So I checked all these capacitors around this chip. They're not shorted. I'll go ahead and demonstrate that. I'll go into continuity mode. Or we can go diode mode, but we'll do continuity. You probably be able to hear the beep or not. You may not be able to hear the beep, but if I check, if I put probe on ground, that side's ground and that side's good. Ground, good. Good, ground, good. I checked all those. I checked all the ones over here. This one was kind of dodgy, so I replaced it. It's a 1 microfarad capacitor. So I was like, man, this was racking my brain because this chip seems fine. It's getting power. So I've been digging a little deeper, and if you look on the back of the board, I can't zoom out any further, but let me just show you here. Take that off. If you look on the back of the board right here is a Maxim chip. It's a Max 77260, and it's a PCMI power chip, power management chip. It's a BGA chip. So let's go back to this one, and now let's take a look at this chip here. Okay, so I was like, you know, some of these caps don't look great. You see some of my probe marks from testing. But, you know, I was like, these caps over here don't look like the best right here. And these don't look too good. But if you check those, let me go back over here. And what I'm going to do is I'm going to clip this to my USB-C port because I know that's ground. And if I check these capacitors, that's ground, that's not, ground's in the middle of these two. And then I was like, okay, so none of these are, these two are ground, nothing. Then I checked this guy right here. This guy right here, ground and 25 ohms. So, I believe this is a short. And if I go over to diode mode, real quick, so we saw it in resistance. And if I touch this side, I get 0. It's going to beep on me. And then if I go to this side, it's 0.042 millivolts. So 42 millivolts to ground. Now, I'm not 100% sure if that cap is part of this power management circuit. What I see here is next to it appears to be inductors, and this is a little bit larger of a cap. I believe it could be a 12. No, I don't think it's a 1206. I think it's still an 805. It's an 805 cap, 0805, and it's got some inductors around it. So that means it's either stepping down the voltage or stepping up the voltage. But I looked at the cap and I'm like, okay, well, is my cap shorted? Well, I don't think my cap is shorted because if I go back to this and this, now I'm going to have to slide this and take the microscope off. So if I come back to this cap with my LCR meter here, and in resistance mode, it's in resistance mode. Let's see if I can zoom you in a little bit. It's in resistance mode, and I come in here and I check this capacitor here. It's going to read 164 megohms, but it reads megohms, so I don't think the direct short is across the capacitor. It even measures a series capacitance. If I put it on auto, it'll measure it as a 58 microfarad capacitor with a series resistance of 11 ohms. I don't know if that's an exact reading, because if I read this capacitor over here on this battery management chip right here, if I measure this one right here, I know this is 1 microfarad. And it's reading as 4 microfarad because it appears to be in series with some other ones. So it's adding up, but it's 4 microfarad. So I know that's 1 microfarad because I pulled it off and checked it with a donor board. It's 1 microfarad. So it makes me wonder that I've seen these switches that this is my first time doing board level repair, and I've seen switches that have, this chip, this BQ chip go bad, and this M92 chip, and I never replaced them. I just used them for game card slot readers or flash memory, or, if the screen was good and things like that. But I want to start repairing these logic boards. And when I purchased this, again, I talked about this, but I asked the guy, has it ever been opened or worked on? He's like, no, I've never opened it or worked on it. Yeah, he's never opened it and worked on it. But when I got it, you can see that the USB port was replaced. It was covered in flux. You can see the flux remnants on the water sticker, and you could definitely tell that this chip was replaced. Now, I believe that this chip and the USB port were replaced correctly, because I plugged in a USB lead and I checked continuity based on the pins I know to these pins these pins here, and it appears to be soldered well. A little bit more could go into the back here. I'll touch that up if I get this working. There's a lot of things I'm going to do to this if I get it working. But I checked the components to see if there's a short. I check all these capacitors, and then I check all the capacitors here, and then I flip the board over and I check this P13 USB chip. I check that. I check these filters here, and I can change these filters now. I check these capacitors, and everything seemed to be good. If I come over here and I check, where's my ground here? I'll come in here and I'll check these capacitors here. That's an open line. Oh, it's supposed to be red probe on ground. That's my bad. That was my bad on that. I had that mixed up. So let's check this again. So red probe on ground, and then I check. Oh, where's it at? I check these capacitors here. Like right there's ground, and there it's open. So, and then if I come back over here to this right here, and I touch that side, see, I still get that same low reading. So I believe I don't, like I said, I don't believe it's the capacitor. Guys, if you think it's the capacitor, let me know. I don't want to, I'm going to hold up until after I post the series of videos to see what kind of comments I get on what you guys think I should do. But knowing that I found a shorted cap on this, around this Max, there you can see the number right there, this Max 77620, it is a BGA chip, and I've reballed BGA chips to just as a practice thing at my old job, because we thought we were going to use one. So I got stencils, I practiced doing it, and I got it down to where I could do it. I've never pulled a chip and installed a new chip, or removed a chip and then put balls on it and reinstalled it. But I am now going to go through here and check all these capacitors, like ground, no, ground, so nothing open. So I don't think any of the CPUs are shorted. Okay, that's interesting. That capacitor is, oh no, that's not. Let's see what it is in continuity mode. I normally work with ohms. I'll check out. That actually might be a low resistance to ground. Yeah, 74 ohms. That could be legitimate. Yeah. So now I don't have any known good switches here, but I will. I have one that I purchased that it doesn't play. It plays. It works great. It just, the digitizer scratched up, and it doesn't connect to the dock and go to the TV. It charges on the dock, but it doesn't go to the TV. And I ordered it. I got it, and he sent the dock separately with the switch. Switch hasn't arrived yet, and I got the dock already, and the dock's bad. So I'm thinking there might be anything wrong with the switch. But if it works and it plays, and if it's a playing on the TV thing, I know it's most likely going to be this audio video chip, and power charge control chip here, this combo chip M92, so I can replace that. But I can also use it to check to see if this truly is the way it's supposed to be on a working switch. Like I said, I don't have a known good board here right now, but whether I fix this one all the way, or if I fix this one all the way, or I don't, I'm sorry, if I fix this, I am going to keep it most likely as a known good, or I'm going to keep the other one that's coming that doesn't connect to the dock as a known good board. But I've come to realize that it's nice to try to fix these one-offs, one at, like I get one, I fix it, I resell it. But it's come down to doing these board level repairs and taking readings and something and then trying to look up if that reading's correct. I think it would benefit me to have a known good board. So I am going to, like I said, I'm going to, if I can fix this, keep this one because this one was cheaper, and the one that works that doesn't connect to the dock costs a little bit more. So I'll see which one I can get working, and I'm going to keep it as a known good board and then continue with move on to another switch, knowing I have one good working switch that I can use for measuring and stuff. And this one is, like I did a bid auction on this and I got it for $100 with free shipping. And again, but when I bid on it, I asked the guy, have you ever opened it or worked on it? And he said, no, I never worked on it. And when I got it, when I first got it, I saw some silvering around the screws, but I wiped them with a cotton swab and it went away, so it didn't look like it was open. And then as I started to tear it down, I realized there's a screw missing behind the kickstand, and one of the screws on the rail was stripped out. I had to drill it out. So, and then they were screwed in with such force that I have to replace all the screws on the rail. The battery is a generic cheap Chinese battery that has half the capacity of a normal switch battery. Also, it would need a new digitizer. It would need a new back case. The back case just looks like a cat got to it, as my son said. The back case looks like a cat got to it. It's hard to see it on the camera, but there you go. You can see how it is all chewed up and mangled. So, new back case, the kickstand, surprisingly, I heard these kickstands break, but surprisingly, this kickstand still works. So, yeah, I'm not sure about that. So, the kickstand's still good, but, I don't need, for the good working one, I don't need a kickstand, so I can use that as a replacement. It looks like actually that kickstand may be a replacement, is one of the things he replaced. They did put new thermal paste on it. None of the ribbon cables were damaged. The left rail got damaged from me trying to drill out the screw. And then the battery case is a little bit damaged from where they pried the battery out. You can see this right here. Right here you can see some more light on it. You can see that the battery case was damaged. So I'm finding all these little things wrong with it that if I replace the case and whatever's wrong, reball that chip or fix that chip, and then a new back cover, new left rail. I'm putting a good amount. I would make money off of it, but I think it would be more valuable because I got, after sending a message to the seller saying, hey, look, dude, this was open. I got video proof of that this was opened. And he's like, oh, dude, I'll give you $20 off. So I'm like, okay. So I took the $20 off. So $80 for this. If I get it to work, it's a known good board for $80. I tested the I've tested a lot of these components. The SD card reader is good. The game cartridge model is good and very clean inside. It's very clean inside. And the memory is good. The memory is good. So all that's good. So, I could use those as known goods when testing a broken switch. So, like I said, if I can get this board to work, I think keeping it as a known good board would be probably advantageous to me to do that. Because I'm concerned, yeah, I could refurbish it and get it to work. But you go to sell it on eBay and you're like, okay, so the battery's been replaced. The BQ chip's been replaced. The USB port's been replaced. This Max 77620 chip's been replaced. The back cover's been replaced. The rail's been replaced. The digitizer's been replaced. People are less likely to pay a good price, a higher price for something that has that much work done on it. Yeah, it has a new screen with no scratches on it. And, if I get it working, $80 if I can get it working for, $20, the cost of this chip, and I sell it for, $200 as a working switch, I'd still make $100, but I still think it would be more worthwhile to have a known good board and known good modules that I can test other systems with, because I've watched a lot of videos, and the coder, he's a good channel. Subscribe to his channel. He's a pretty cool guy, very helpful, and it seems like I've seen him work on a few switches, and it seems like he always troubleshoots with known good parts. And I have a known good battery. I picked up one of those, and that's the other thing. Like, I have a known good battery, but I really don't have a way to fully charge it. So if I have a working switch, I can fully charge the battery anytime I need it charged. So that way I have a known good battery at 100%. So, but that is where I'm at on this. More of a diagnosis and a rant about what might be wrong. You guys let me know what you think might be wrong. If you think I'm reading that capacitor wrong, let me know. Because it could very well be designed to be that low of a value of 45 ohms. Because I have my threshold set to 50 ohms. And if you just measure the resistance of it. Let me put mine back on 2-wire resistance. Put my meter up there. And we'll put that clip on the USB port. We'll bring up the microscope camera again, and we'll come back over to that chip right there. And if you measure the resistance of it, right there is 39 ohms. And that doesn't seem right to me. That seems low. That seems shorty. Even this one beeped in diode mode, and it is, 0.22 ohms. What is it on this side? 173 ohms. So, well, now it's reading lower. 49 ohms. Why is that? Oh, it must be charging and discharging or something. That is weird why I keep getting two different readings. So that's 49 ohms. So, this could be a low voltage rail, like 0.9 volts. A very low rail, and it doesn't need that much of a resistance to ground to function. So if this is a very low voltage line that doesn't see a lot of amperage, that low of a resistance to ground isn't going to, that could not be a problem. And you see that a lot on electronics, to where you have different power rails. Sometimes you have a 3.3, a 5 volt The lowest I've ever dealt with was 3.3, and I don't know what the power rails on this switch are. I know that if you plug it into the charger, it'll ask for 15 volts, and then you have a inductor here and some capacitors, filter capacitors that probably step down the voltage to 4.2 volts to charge the battery. That's probably what this does here. And then you have a inductor and 2 capacitors over here giving power to this chip. I don't know what this chip is. Do I have it on my reference sheet here? What is that chip? Yeah, that's an unknown DOC 551. So that's an unknown chip. So it's got its own little power regulator unit there to probably regulate the power it's getting down more. But if you look on the back here, this is, you have another inductor, 2 capacitors here. I'm not sure if I know what that chip is. That chip. On this side of the board now. So yeah, that's another unknown chip to me. I have the partial part number. And, there's your audio. There's no, so this is getting the step down voltage probably already, but again, taking you back, and then here there is another inductor, 2 capacitors, and a diode. That's going to be another power supply. Right over here is an inductor and that another power supply for whatever this chip is. Probably another, low voltage. But if you go back to the area in question, you have, inductor. So you basically have probably 5 voltage regulation circuits here. You have the 5 inductors. These 2 inductors might share these 2 capacitors. These 2 might share this 1 capacitor. No, 2 capacitors. So, you got inductor, capacitor, capacitor, inductor, capacitor, capacitor, inductor, capacitor, capacitor, inductor, capacitor, capacitor, inductor, capacitor, capacitor. So they all have their own capacitors apparently. So, like I said, I don't know if, getting 42 ohms is considered a short. If this is, like I said, if this is a low power line, I mean a low power line, 0.9 volts, 1.8 volts, that could be a resistance that you need to get there, but I'm not sure. Like I said, if you guys think you know what's going on there, if I should even not worry about this, I'm going to wait till I get the working switch and test it to see if it's the same. If it is, it'll be in the next video. I have rambled on for 30 minutes, and I am done rambling. Thank you so much for watching. Here's the links to social media and links to Patreon. I hope you guys have a fantastic day. Thank you.